Hello, everybody, and welcome to another episode of T-Rex Talk, podcast exclusive. And in this episode, we're going to be talking about radio communication, specifically a single category of radio communication and some of the recent developments, kind of where things are at in the year 2022, because there are some interesting developments and some new projects that are worth mentioning. Now, as you know, there's a whole bunch of different categories of radio communication. There's the public safety radio, which is your police, fire, EMS radios. These are issued pre-programmed radios that these guys carry, and there's a network of fixed repeaters generally covering an entire county or a state. Military radios are kind of the same thing, only more rugged, more secure, and more complicated because military radios are often on different types of vehicles and need to communicate different types of data, and there's a larger and more complicated command structure that has a lot more different layers in it, so there's a lot more different radio networks. And then you have your amateur radio, which is kind of everything from little tiny Morse code radios that can talk to the other side of the world but fit inside of an Altoids tin, or base stations in your basement that pump out hundreds and hundreds of watts into giant antennas, or handheld stuff and fox hunting and contesting and a whole bunch of other sort of hobby-related activities. And then a subset of that amateur radio is kind of, I would call, for lack of a better word, prepared citizen radio. There's a subset of that group that is more focused on emergency communications than the hobby aspect. They're more interested in being able to make consistent, reliable communication, consistent, reliable contacts with specific people than random stuff. I think there's been a huge amount of growth in this area over the last few years. And it's an area that I've really focused on studying over the last few years, and I've also learned a lot. And I've also sort of been dividing the types of radio communication that exist into some different categories. So in the small squad category, these are a group of people that you are in really close contact with. You're out on the range together, or you're out in the woods together, or you're doing search and rescue type stuff together, or if you're less optimistic, search and recovery type work together. You're spread out over a few miles, but you're not spread out over the entire county. And one of the things that you want to be able to do is talk to your guys using real-time radio, and that's pretty easy. A few miles is a piece of cake with handhelds. But you also probably want to hand each other location data and some small text data because in my experience, 90% of the radio chatter in this type of scenario is, "Where are you? I'm not sure. What can you see? It's trees to the left of me and trees to the right of me. Oh, does that mean that you're on this ridge? I don't know. I'm actually not on a ridge," etc., etc., etc. So being able to simply have your radio chirp its location on a map to somebody else who has the ability to see that location on a map saves a ton of time. The next category would be county-wide communication. I've divided that into probably 3 different categories. The ability to send emergency text message to different people is really, really helpful for exactly the same reason that inside of that tiny, small squad scenario, the ability to send text data is important. And there are scenarios in which that larger emergency voice capability is very important. But I also think that counties should have a non-emergency way for people to communicate, sort of general text messages. Probably doesn't need to be voice. You probably don't need to be able to get on the phone directly with people on the other side of the county. And then it is very helpful to be able to talk nationwide, to be able to find out what else is going on in other parts of the country. And for that, you're in another category of radio. HF radio is probably the way to go, and there's a lot of different ways to do this. There is text data, like those little Morse code radios that I talked about that fit inside the Altoids tin. Those are capable of communicating nationwide or further, but only on Morse code. So you're sending text messages using a Morse code key, or you're connecting that radio to a computer, letting it translate the text that you type with the keyboard into Morse code or PSK31 or JS8 call or some other digital mode of text. And communicating text data slowly lets you use a lot less power, and it just gives you a lot more flexibility in a bunch of ways. But that being said, there's also times when you might want to have a two-way voice communication. So the ability to use more power to talk to people with a microphone and hear them on a speaker can be kind of useful. And there's actually another category that I think is extremely helpful in an emergency scenario, and that is the ability to broadcast voice. Now, as you know, broadcasting is not something that amateur radio people are supposed to do. We're supposed to transmit, not broadcast. But shortwave radio stations are a really capable way of getting information a really long way. And listening to shortwave radio is very easy, way easier to listen to stuff that's happening in the HF range than actually talking on it. So I really think that our community should have a few shortwave radio stations that are broadcasting or perhaps widely transmitting voice information that you can listen to on a $100 shortwave receiver or $50 shortwave receiver. That would be a great way to communicate information, one-way communication, widely across a huge amount of area with not a ton of resources. That is something that can go an incredibly long ways and connect to a very, very large amount of people if they just have those shortwave receivers. So that is something that I think this emergency preparedness community should probably give a little bit more thought to. But now I want to get down to some specific tools and developments that have happened. A couple of years ago, I made a video on how to shoot, move, and communicate, and that was where I talked about ATAC and I talked about APRS, this analog location data protocol that ham radio guys use. And I talked about how useful it would be to have location data and text messages visible on a map like ATAC or like Osmond, which is my current and actually was then, and it still is now, my favorite offline mapping solution. But ATAC has become more widely available and easier to install, and there's a lot more tutorials on how to use it, so the barrier to entry to ATAC is way lower than it was back when I made that video. There are a few plugins that allow you to communicate your location data over analog radio, so you can plug even your lowly Baofeng into your phone with the right cable or a Bluetooth terminal node connector. Terminal node controller, I think is actually the right term, and send location data that ATAC is going to display on the map. And there's actually a couple of plugins that are doing that. One is inside of ATAC, the other one is currently being developed, and it actually uses APRS Droid to do the actual radio modem works, which makes it far more reliable and dependable based on what I hear. So the ability to send analog open communication data over the APRS protocol and see it inside of ATAC is something that is becoming doable. However, it's still a little clunky. It's still all unencrypted. It's still all analog. If you want a more secure way to do this, the best solution is probably Meshtastic. Meshtastic is an open source radio system that does offer encryption and offers mesh networking and a bunch of really cool stuff on top of Internet of Things hardware. So T-beams and various other development boards that have low raw radios on them. They operate in the 900 megahertz range, no licenses required, very, very low power, but you manage to get a lot of range out of these radios, a surprising amount of range for the wattage just based on the protocol that is being used. The sheer efficiency of what is being communicated, and the data rates are very, very slow. But that's okay when you are communicating your geographic position or a really short text message that has been compressed and encrypted and sent over this. So Meshtastic is something that a bunch of guys have been tinkering with for the last couple of years, myself included. There is a Meshtastic plugin for ATAC that works well. So for this really small unit coordination stuff, Meshtastic and ATAC is a pretty good solution. The biggest downside is the hardware for a couple of reasons. Number one, there's a massive chip shortage right now that makes it very hard to actually get the hardware. There's not a whole lot of it in stock here in the United States. There's a huge wait getting it from other places. And most of what exists is little development boards that you still have to connect stuff to, and it doesn't come with a case. And the case that you 3D print is probably not going to be waterproof, because I haven't figured out how to do that reliably yet. But the technology is there, and it really works pretty well. And if you had the right hardware and you had a durable offline case, I think it would be a pretty useful solution for a whole bunch of different scenarios. And I know that this is the case because the larger public safety and military community already has products that are using it. There's a company called Otto that makes a lot of pretty high-end radio equipment. And they have recently begun selling a device called the Lynq Pro, spelled Lynq. And it is a little tiny device that clips onto your webbing, and it talks over Bluetooth to your phone, just like a Meshtastic node. And it talks over ATAC, just like Meshtastic does. And it talks directly to ATAC using the exact same protocols that Meshtastic does. So I think that it's basically the exact same thing, but a larger, more expensive industrial version. It has some limitations. The maximum users that you can have on a single mesh is 24, and there's no price on the website. You have to contact them for a price. That's how you know that it's expensive. I did contact them asking about it, and they haven't written back yet. So that means it's probably going to be really expensive. And Meshtastic is not the only long-range, low-power encrypted data method for communicating over LoRa. There's a couple of other projects that exist. There's one called QMesh, which requires a little bit more sophisticated hardware, but it has a much more sophisticated meshing algorithm, so you could easily run way more than 24 users on a mesh. And then there's one called Ripple, which has a whole bunch of very cool applications being built around it. So this is a very interesting area to study. This is the area that has probably seen the most development. Next category, DMR radios. This prepared citizen community has really coalesced around DMR radios. Yes, the UV5R Baofeng is still king when it comes to total market saturation, but the DMR radios are really where the serious folks have kind of landed. They're not using other digital modes like D-Star as much as they are using DMR. There's a bunch of DMR radios that are out there. There's a bunch of new tools for programming, like there's an app called DMR Tools that lets you program code plugs for radios inside of a browser. There's a steeper learning curve with DMR. The radios are a little bit more expensive and the learning curve is a little bit steeper, but there's a lot of support for the TYT-based radios, including custom firmwares that do very cool things. So that's an interesting version. The 390 is a waterproof radio, but if you want the 256-bit AES encryption, you're going to need to go with a more expensive radio like the Hytera. Anytone makes a radio that is very, it's much more affordable, but it is less rugged. And then Maxon makes some DMR radios that support that encryption method, but I haven't actually heard a whole lot of reviews on those yet, so I'm still waiting before I recommend those. The other thing that I'm seeing in this community is an awful lot of people using Motorola radios that they buy in bulk or they buy heavily used from police stations, EMS, fire, etc. So I have very mixed feelings about Motorola. The company, in general, in the past, was very cool. That company no longer exists. The company that focuses specifically on selling radios in the public safety sector to government employees is a lot less cool. The reason that you aren't buying these radios brand new is because they have ginormously inflated price tags because there are grants. There are tax grants that allow these different departments to buy these radios, and so Motorola has inflated the prices to take advantage of all of that grant money that exists. And if you buy these radios used, they really don't want to support you. They are very, very picky about who uses the radios and who uses the software to program the radios, which is highly necessary. But what I have noticed over the last couple of years is the number of people that have that software without Motorola's permission and have a really good understanding of how those P25 and other trunking systems work and how to program the radio so they work well together without Motorola's blessing. There's a lot more of those guys. So if you can find a group of people who are using this technology, it is much easier to support now than it was in the past. So I'm seeing significant growth in that particular area. If you can find these used radios and people who know a lot about them and can help you support them, that's great. It's not something that I would recommend that you jump into and try to do on your own. These are not front panel programmable radios by any stretch of the imagination. And then for the larger, wider communications capability, there's a project that I'm super excited about that I didn't even find out about till this year. There's a guy on YouTube called The Tech Prepper, and I'm going to link to his channel, and he is developing a new set of software radio tools called EmComm tools. This is probably the thing that I am most excited about of everything, because in the amateur radio world, a lot of these software tools they're like what you'd imagine amateur radio guys would make. Most of them run on Linux. They're really weird. The interfaces are strange. They're kind of hard to tinker and use. But what EmComm tools is basically a front end for all of those very cool Linux ham radio tools and messaging modes that work really well but are just hard to actually learn the interface for. So this front end will let you do a whole bunch of different stuff just using drop-down menus and tabs on the front end. APRS location data, text, SMS over APRS, email over WinLink, all the FLDigi modes finally available to you in a human-readable format, et cetera, et cetera. But it's more than that. Tech Prepper is adding a bunch of other stuff like he's a search engine guy. He's a professional programmer, and he builds search engines. So he's built out databases of all of the ham radio call signs, all of the ham radio repeaters, and made them really easy to find and use and sort based on a whole bunch of criteria, including geographic data. And EmComm Tools includes an offline open source mapping server. So you have access to map data completely offline, searchable, etc. And this program runs on Linux, but it has a web server in it so that if you have it running on a Raspberry Pi in your backpack, for example, you can connect to that Raspberry Pi over Wi-Fi and use your phone to look at a web server that's on there. And so you can use the whole interface of this program on your phone without having any apps installed. So it's just a fantastic collection of a whole bunch of technologies all working together the way that they're supposed to, the way that you would want them to work for this particular use case. Now, I will say that it's not working perfectly yet. This is something that he's developing. He's talking about the process. He's getting feedback from different people. I think that he's planning to have the beta testing this spring, and then this tool being more widely available in the summer. But I'm going to link down in the show notes where this project is being developed so you can keep an eye on it. I'm super excited by it. His current build is really neat. He's got a Linux tablet in his backpack that is running this program, and it is connected to a VHF UHF mobile radio in a backpack. So he's got many, many watts of transmitting power, and he's able to do just a huge amount of stuff from his phone or from, if he wants a bigger screen, that tablet running Linux. Tons of communication capability, the ability to just look up repeaters based on where he is, get a compass heading directly for where he needs to point a directional antenna. All kinds of location data appears on the map the way that you would expect it to. And there's a whole bunch of things that he could add to it in the future that are really exciting. Things like a ATAC plugin so that all of these modes now communicate location data directly to ATAC, or running an ATAC server so that everybody else that is out communicating with him are syncing data to his server and communicating it on. Mesh network stuff, forwarding stuff, just a lot of really, really cool things that could be added to this particular system. And it's happening very quickly because very little of it is being built entirely from scratch. It's leveraging a whole bunch of really useful work that already has been done by other people, which means that it's very widely compatible with a whole bunch of people who are already out there using one or two of these tools already. There's also a whole bunch of fascinating work being done in the SDR space, which is primarily receive only, but it's really useful for gathering signals intelligence. So RTL SDR folks have built something called the Kraken, which is something that they're going to release shortly. It is 5 clock synced receivers. So you have 5 radio receivers, and they're all synced up perfectly to exactly the same clock so that you can do direction finding really well. If you had a unit like this on top of a car with 5 different antennas, you would be able to really quickly and easily see exactly where different signals are coming from. I'd actually love to have one of these things on my house. It would be a really cool thing to have on the top of my house to use for various radio type things, but also to see if any drones are flying by, to see what sort of new radio traffic is suddenly in my area and which direction it is coming from. That would just be a super cool thing to have on my roof, sending me alerts as new stuff is picked up. Just someone should develop that. But basically, there's a whole bunch of stuff that is being developed right now, and a whole bunch of growth inside of this smaller community that in the ham community a few years ago was really not a well-served sector. People who are interested in these emergency communication things. And I see a tremendous opportunity for growth in here. As people have gotten better at working with the Motorola radios, as they've gotten better at setting up DMR specifically for these types of tasks, as Meshtastic has gotten better, as software programmers who have skills to bring to this area and want to solve some of these exact problems have built out stuff that we can run on Raspberry Pis or laptops or tablets. More and more capabilities become available to us. And then as these are adopted, the actual communication networks become stronger and better. So I'm really excited about different opportunities for things in 2022 as we develop tools specifically for these different categories that I mentioned before. The small squad search and rescue scenario, the county-wide letting people know where resources are needed in an emergency scenario, and then the nationwide what's going on in other parts of the country. Those three zones, and then within those sort of three zones, the ability to do real-time voice communication, the ability to do secure text, data, location, etc. Splitting things off into these different categories, I think, is helpful for understanding exactly what problems we're trying to solve. But eventually, I would like to try to bring all these things a little more tightly together. So, for example, there's a bunch of people who are going to be running that auto LoRa location tracker for small squads on one shoulder, and then on the other shoulder, they're going to have a push-to-talk device for their voice radio. They're going to be running multiple radios to accomplish both of these small squad tasks. And I think that that is fine. In some ways, that's actually better because it provides you with a level of redundancy. It provides you with a couple of different options. It provides you with a little bit of frequency agility, sort of. But if you had all that stuff in a single radio, that would be kind of cool. It would simplify things for other folks. It would simplify things for people who aren't able to run that much kit or don't want to manage that many networks. And I think that we should push for the FCC to loosen some of the restrictions. Some of the bottlenecks that we are running into have to do with the FCC and what is actually allowed on the ham radio bands. Developing these things is exactly what amateur radio exists for. And yet, there are some restrictions. There are some speed limits, like actual literal speed limits on how quickly you can send data in certain bands using certain modes. There's a ban on all encryption, which is actually really problematic. Not because I'm necessarily trying to hide everything that I say, but this podcast you're listening to right now, if you're listening to this on a web page, I am 90% sure that the browser window that you have open is technically encrypted. If you wanted to do just basic web stuff over amateur radio, it is going to be encrypted, and you can't do that simply because of that limitation. So I feel like we need to figure out how to lobby, how to push the FCC to expand what is allowed on certain ham radio bands. And if we could do more of this digital radio stuff, some of this mesh-tastic type stuff down in the UHF space, that would be phenomenal. I think that we would get some incredible opportunities opening up there. So that's something that I'm going to be working on this year, trying to figure out what is actually involved in that. If you happen to be an FCC lawyer, if you happen to be someone who works in this space, please reach out and contact me, because I'm trying to figure that out. And I know that this stuff happens in the larger commercial world. So Garmin, for example, they sell off-roading radios that work with their ridiculously overpowered off-roading tablets. They managed to get an exception to push digital text and location data over MERS. That you're not supposed to use any type of digital data communication over that particular frequency, and they got a specific exemption for their specific radios. So I know that this is very doable in certain spaces, and it's the sort of thing that we can work together and get more out of as a community. So thank you very much for listening to this sort of scattered explanation of recent developments in the radio space, stuff that I'm currently excited by, stuff that's currently developing in what I think is a really, really good direction. And I want to thank you guys that have been a part of it, not just people who have been developing the tools like Tech Prepper, not just people who have been coordinating on places like the Gray Man server, for example. I'm going to put a link in the show notes to coordinate getting Motorola radios programmed properly and set up so that they can be used by citizens, but just this general move in this direction. People who are adopting ham radio technology, using ham radio frequencies, but with a more specific emergency preparedness and emergency communication purpose. The amount of interest in this area is what has really driven a lot of these things. So I'm really grateful for all of you that are doing that. And I think that there's a whole bunch more low-hanging fruit that we can get in that area. And then a lot of incredibly useful, incredibly valuable, not so low for hanging fruit that we can go after. So as a community, I'm looking forward to seeing what continued developments look like. So check out the show notes for links to some of these different projects. And again, if you personally happen to be a lawyer who directly works with and around FCC regulations and knows how that lobbying process works, feel free to contact me at team@trex-arms.com, because that would be an interesting project for us to take on together.